Alright, let's take a look at another example here. This time we've got equals 2x minus 1 over x. So again, let's walk our way through our steps. So step number 1 says to simplify. And again, one term on the bottom, first degree or linear on top, so nothing to simplify there. So that step's done. So step 2. Step 2 said let's find the y-intercepts. So remember, for the y-intercepts we let all the x's be 0. So we're just going to get 2 times 0 minus 1 all over 0. Now with 0 on the bottom, that means undefined, which also means we're going to have no y-intercepts. So that's not going to help us anything. So far we've got really nothing to do with our graph. Our third step is to find our x-intercepts. And again, for our x-intercepts, we just let our numerator equal 0. So in this case, 2x minus 1. So here we would add 1 to both sides and divide by 2, and x equals 1/2. So right here, x equals positive 1/2 is our only x-intercept. Right, fourth step. Fourth step says we should find our horizontal asymptotes, or our vertical asymptotes, sorry. Our vertical asymptotes. So for our vertical asymptotes, again, we're looking at our exponents, we're doing our bottom, a little late at night here. So we're just going to say for our vertical asymptote, we let our denominator equal 0. So there, x equals 0, we did. That's all there is. So x equals 0, right here, our y-axis itself actually turns into a vertical asymptote. So we got that. Horizontal asymptote, since I jumped the gun before, we might as well hit it now. Horizontal asymptote was using our rules. So here we have first degree, and if they were equal to each other, then that said we took the two lead coefficients, in this case 2 over 1, and that became the equation for our horizontal asymptote. So this one's going to be at y equals 2. So our horizontal asymptote is going to go right there. Step 6, we do our regions and our test point. So this one, we're going to have one region off to the left, one region off to the right. Alright, so this one, let's pick any value we want over here. The right region's already done because we do have a value to the right of this, so we can actually start our magnet right away and draw this going towards that horizontal asymptote and towards this vertical asymptote. So there's our first curve, which is kind of an ugly curve right now the way I drew it freehand. So over here we can take any value to the left. So let's take something that's easy. So let's take -1. So over here, if I plug -1 in for x, my top value is going to become 2 times -1 minus 1. My bottom is going to become -1. So if we simplify that, 2 times -1 is -2, minus 1 is -3, over -1, which is just 3. So we did -1, 3, which is up here. And since that's on top, we're going to do everything above our horizontal asymptote here, and then curve this on this side towards the vertical asymptote. So there's our picture for 2x minus 1 all over x. Alright, I think we should be able to take a look at one other problem here. Oh yeah. So let's take a look at one more here. And this one gets a little bit more extreme, and a few more things that we can do with this one. So here's our equation. F of x equals x over x squared minus x minus 2. So we'll get ready here to set up our graph. So the graph is set up. So let's do our work here. So number one says simplify. This time we do have something we can simplify. The top, no, nothing can happen with that other than what's already there. The bottom, though, will reduce to x minus 2, x plus 1. We looked at one of these a little bit earlier that was somewhat similar. The factoring is good to look at to see if anything will cancel. Again, this time nothing did, but at least we took care of our simplification. All right, step number 2, we're going to look for our y-intercept. So our y-intercept, we let the x's equal 0. Now another way we can do this without the factoring and plugging everything in is we can basically just say everywhere there's an x, it's going to turn to 0 and go away. So this is going to leave us with 0 over 2, which is just equal to 0. So our y-intercept is here at 0. And that's going to be the only place where we get a y-intercept. All right, 3, our x-intercept. Our x-intercept, we let our numerator equal 0. So x equals 0. That one didn't change a whole lot. So that's also there. So we've got that point already marked off twice, but that also tells me that's the only place on my x-axis, my y-axis, that I'm even going to touch either of those axes. All right, number 4, we get to our vertical asymptote. And this is where it did help to do this, because now we're setting our denominators and trying to find the zeros. So we're going to have x minus 2 equals 0, and have x plus 1 equals 0. So here, obviously, we're just going to add 2 and get x equals 2. Here we're going to subtract 1 and get x equals negative 1. Those are our vertical asymptotes. So we're going to take those at x equals 2 and draw our vertical asymptote there. And at x equals negative 1. And again, remember, we're not allowed to touch our vertical asymptotes when we do start working with our curves. Alright, that leaves us with horizontal asymptotes. So here we can either use the right side or the left side, but we're going to find out here that first power on top, second power on the bottom, and again, if that's the case, then top is smaller than bottom. Our x-axis, or y equals 0, is the actual asymptote. Now notice something different happened on this one. We do have a value touching the horizontal asymptote. It is possible to touch and cross horizontal asymptotes, not so with vertical. Alright, so we've got that. That was at y equals 0. Alright, now number 6, we're going to do our reads and our test point. So this time we've got a region here. Now actually I'm going to use this x-intercept as well. So I'm going to go between negative 1 and 0 for a second region, between 0 and 2 for a third region, and then out here for a fourth region. So I'm going to take care of the easier ones first. So I'm going to do region 1. All I need to do is pick some value to the left of negative 1 and see if my answer is above 0 or below 0. So for region 1, let's take negative 2. So we're going to say x equals negative 2. So if we solve that, and again, I can put it in the original or over here. I'm going to put it in this one. I'm going to get 2 on top, and then on the bottom, 2 minus 2 is 0. Oops, which number did I get? Negative 2, sorry. So I'm going to get negative 2 on top. Negative 2 minus 2 on the bottom is negative 4. And negative 2 plus 1 is negative 1. So that's going to simplify down to just negative 2 over positive 4, which is negative 1/2. So that being the case, negative 2, negative 1/2 down here, that means the entire part of region 1 is going to be below this. So I'm going to curve it towards, but not quite touching, my vertical asymptote. and towards and not quite touching my horizontal. And again, I know it's not going to touch up there because this was my only x-intercept. So that's my first one. Now I'm going to do region 4, same reason. It's easier out here because I don't have this thing happening in the middle. So for region 4, I think I'm just going to let x equal 3. Something easy over here. So I'm going to end up with 3 on top. On the bottom, 3 minus 2 is 1. And 3 plus 1 is 4. So we're going to get 3/4. So when we plug 3 in, we got 3/4. So we're up. So we're obviously going to be on top. So we're going to take this and we're going to graph it and again go towards. And boy, this is a lot easier on paper than it is on the computer. So we're going to go towards each of the asymptotes like they're magnets. And we've got that. So now our part in the middle. I'm going to pick a value to the right. So I'm going to pick 1 for region 3. So if I plug that in, I'm going to get 1 on top. On the bottom, 1 minus 2 is negative 1. And 1 plus 1 is 2. So here I get 1 over negative 2, or negative 1/2. So I'm down here. Now that tells me this is going to curve down towards that asymptote. Now I have to still do a value for region 2 here because I don't know if this is going to curve back up or if it's going to turn and come back down. It's got to do one of the two. So we're going to let negative 1/2 happen for region 2. So if we do that, on top we get negative 1/2. On the bottom, negative 1/2 minus 2 is negative 2.5, or negative 5/2. And negative 1/2 plus 1 is 1/2. So if we multiply those together, we get negative 5/2, or negative 5/4. So we can multiply this by negative 4/5 as our reciprocal to simplify our fraction. And we're going to get a positive value, which means we're going to be above the x-axis. So this one's going to turn and go up this direction. So there's our picture. A little more complicated, a little more work to be shown on that one as well. So there's another example.